Most people think ocean shipping is simple. A factory makes something. A container carries it. A ship moves it across the ocean. And a few weeks later, it arrives at a store near you. That sounds clean, almost invisible. But the strange thing is this: the system that moves most of the world's physical goods is not built like a normal delivery service. It is built like a giant machine where every small delay spreads into another delay. A container can cross an entire ocean faster than it can leave a crowded port. A ship can carry more than 20,000 containers, but still wait days just to unload. And sometimes the cheapest decision is not to move faster, but to slow down. Modern container ships can carry around 24,000 TEU, and ports like Los Angeles handle millions of containers each year. But that is not the strangest part. Because the real problem begins after the ship arrives. The most important object in global trade is not the ship. It is the container. A steel box with standard dimensions changed the world because it made cargo easy to stack, easy to count, easy to move, and easy to transfer from ship to truck to train. Before containers, cargo had to be loaded piece by piece. Bags, crates, barrels, machines, furniture, everything needed separate handling. That was slow, expensive, and messy. But once the world agreed to use standard containers, shipping became almost mechanical. A container could leave a factory in Asia, go by truck to a port, move onto a ship, cross the ocean, get unloaded, and then continue by rail or truck inland. That flow is still the basic structure of container shipping today. But standardization created a hidden weakness. Because when everything depends on one perfectly timed chain, one delay does not stay in one place. It moves. And the first place it moves is the port. A ship is only useful when it is moving. But global shipping depends on places where ships stop. Ports are not just parking lots for ships, they are the transfer points between the ocean economy and the land economy. A ship arrives, cranes remove containers, trucks move them inside the terminal. Some containers go to rail, others wait for drivers, some are inspected, some are stacked, some cannot move because the customer is not ready. So the port becomes a buffer. And that buffer has limits. When everything works, a port feels invisible. Goods appear in stores, factories get parts, and consumers never think about the ocean. But when the port gets crowded, the entire system starts slowing down. Because a container ship is not waiting for one thing. It is waiting for a berth, cranes, workers, trucks, chassis, warehouse space, customs clearance, and inland transportation. And if even one of those things is missing, the ship waits. But here is where it gets more confusing. The ship waiting outside the port is not always the real problem. It is usually a symptom. When people imagine port congestion, they picture ships waiting outside. But the real traffic jam often happens on land. A container is unloaded from a ship, but it still needs somewhere to go. If there are not enough trucks, it stays at the terminal. If warehouses are full, trucks cannot deliver it. If rail yards are backed up, containers cannot move inland. And if containers cannot leave, the port runs out of space. That means new containers from ships have nowhere to be placed. So cranes slow down. Ships take longer to unload. More ships wait outside. And then freight rates can rise because available ship capacity is effectively trapped at ports instead of moving cargo. This is why a small overload can become a much bigger delay. It works like traffic on a highway. A road does not need to be completely blocked to become slow, it only needs to go slightly above capacity. And once it does, the slowdown multiplies. But ocean shipping has another weakness most people never see. The container itself can become the problem. A container seems simple. But it has to be in the right place at the right time. If a factory in Vietnam needs an empty container, that box has to exist nearby. If it is sitting empty in Los Angeles, it is useless. And this creates one of the strangest problems in shipping. The world does not only move goods. It also moves empty boxes. When trade is balanced, containers go full in one direction and return full in the other. But global trade is not balanced. Some countries export far more containerized goods than they import, others import more than they export. So containers pile up in the wrong places. A port can be full of boxes and still not have the right boxes where exporters need them. During congestion, this gets worse. If terminals are crowded, they may limit empty container returns. That means empties cannot get back to Asia quickly, then exporters struggle to find containers, then shipping prices rise. So the system breaks in a strange way. There can be too many containers in one place, and not enough containers in another. And that leads to the next hidden force: money. Shipping companies love scale. The bigger the ship, the more containers it can carry on one voyage. And in theory, that lowers the cost per container. The crew does not increase much, the route is the same, the ocean is free, the ship burns more fuel but not in perfect proportion to the number of containers. So the logic is simple. Bigger ships should mean cheaper shipping. That is why the industry kept building larger and larger vessels. Today, the biggest container ships can carry more than 24,000 TEU. But bigger ships also create bigger problems. They need deeper ports, larger cranes, more yard space, more trucks, more rail capacity, more planning. A small ship unloads a small wave of containers. A mega ship unloads a flood. And if the land side cannot absorb that flood quickly, the advantage of size turns into a bottleneck. The ship was built to save money at sea, but the port has to pay the price on land. And this is where the system starts to look less efficient than it seems. A strange thing happened in modern shipping. Companies realized that one way to save money was to move slower. This sounds wrong. If customers want goods quickly, why would a shipping company slow down? The answer is fuel. Ships use huge amounts of fuel and speed is expensive. Moving faster burns much more fuel, moving slower can reduce costs. This practice is often called slow steaming. It became especially important when fuel prices were high and demand was weak. By slowing down, a shipping company could save fuel and reduce how much capacity was available in the market. That second part matters. Because if ships move slower, each round trip takes longer. That means fewer voyages happen in the same period. So slowing down can reduce supply. And when supply is tight, shipping rates can stay stronger. In other words, speed is not always the goal. Profit is. Sometimes the most rational decision is to move cargo slower, not faster. But once you understand that, the entire system begins to feel different. Because shipping is not optimized for your package. It is optimized for the network. A container does not always travel in the way a normal person would expect. It may not go from the closest port to the closest destination. It may move through a hub. It may be transferred from one ship to another. It may travel by sea, then rail, then truck. The route is chosen based on cost, capacity, timing, contracts, and available space. This is why global shipping is not simply geography. It is economics. A longer route can sometimes be cheaper. A slower route can sometimes be better. A crowded port can make a nearby destination less attractive. And a large shipping alliance can decide how containers flow across entire regions. So when a product arrives late, the reason may not be one mistake. It may be the result of dozens of decisions made across a network. Each decision makes sense locally. But together, they can create a system that feels irrational. And this is the real theme of ocean shipping. It is not broken because nobody knows what they are doing. It is broken because everyone is optimizing their own part. Most people never hear the names of shipping companies. But these companies quietly move the physical world. They decide routes, they manage vessels, they sell container space, they coordinate with ports, freight forwarders, exporters, importers, and inland transport providers. But they do not control everything. A shipping line may own the ship but not the port. A port may own the land but private terminal operators may run the cranes. A trucker may move the container but only if a chassis is available. A warehouse may receive goods but only if it has labor and space. So the system is fragmented. Many players are connected, but no single player fully controls the whole chain. This creates a strange situation. When things go right, everyone benefits. When things go wrong, everyone can blame someone else. The ship waited because the terminal was full. The terminal was full because containers were not picked up. Containers were not picked up because warehouses were backed up. Warehouses were backed up because trucks were unavailable. And trucks were unavailable because the port was congested. The circle closes. And nobody can fix it alone. A delay in shipping is not just lost time. It changes money. If a ship waits outside a port, it still costs money to operate. If containers sit too long, storage fees can appear. If trucks wait in lines, drivers lose hours. If factories wait for parts, production slows. If retailers wait for inventory, shelves stay empty. And if everyone expects delays, companies start ordering earlier. That sounds logical. But it creates a new problem. When many companies order early at the same time, demand rises before the goods are actually needed. That puts even more pressure on ports and ships. So fear of delay creates more demand. More demand creates more congestion. More congestion creates more delay. This is why supply chains can become unstable. They are not just physical systems. They are psychological systems too. Every company is reacting to what it thinks might happen next. And when thousands of companies react at once, the system becomes harder to predict. That is when shipping stops feeling like transport. It starts feeling like a financial market. Ocean shipping is one of the reasons globalization became possible. If it were expensive to move goods across oceans, companies would manufacture closer to customers. But container shipping made distance less important. A product could be designed in one country, assembled in another, packaged somewhere else, and sold on the other side of the world. This created lower prices, bigger markets, and global supply chains. But it also created dependence. Factories depend on ships. Retailers depend on ports. Consumers depend on invisible routes they never think about. And countries depend on foreign infrastructure they do not control. This is the hidden trade-off. Cheap shipping made the world more connected. But it also made the world more fragile. Because when one link fails, the effects are not local anymore. A delay at a port can affect prices in another country. A blockage in a canal can affect factories thousands of miles away. A shortage of containers in Asia can affect stores in America. The system became efficient by removing slack. But slack is what protects systems during shocks. And shipping removed a lot of it. It is easy to think shipping problems happen at sea. But many of the biggest problems happen after the ship arrives. The ocean leg is often predictable. The land side is messy. Cities grow around ports, roads get crowded, rail capacity becomes limited, warehouses move inland, labor shortages appear, regulations differ, terminals compete for space. A ship can cross the Pacific in a predictable window. But a container may sit at a terminal because the truck appointment is delayed. That is the strange part. The ocean is huge but simple. The land is smaller but complicated. And ports sit exactly between the two. They are where the clean logic of ships meets the messy reality of cities. That is why building bigger ships does not automatically solve shipping. Sometimes it makes the land problem worse. More containers arrive at once. More trucks are needed at once. More space is needed at once. And if the city cannot absorb that pressure, the port becomes the choke point. The ship was not the bottleneck. The ground was. Calling shipping broken does not mean it fails every day. Actually, the system works so well most of the time that people forget it exists. That is part of the problem. The system became trusted because it was invisible. Companies built business models around it. Factories reduced inventory. Retailers expected fast replenishment. Consumers expected low prices. But when a system becomes that reliable, people stop planning for failure. And then when disruption happens, there is not much room to absorb it. Shipping is broken in a specific way. It is not broken like a machine that never turns on. It is broken like a machine that works beautifully under perfect conditions, but struggles when reality becomes slightly imperfect. Too much demand. Not enough drivers. A port closure. A canal disruption. A labor shortage. A sudden change in tariffs. A shortage of empty containers. None of these has to destroy the system. But each one can slow it. And because everything is connected, slowing one part affects the rest. This is why the system is powerful and fragile. At the same time, the modern shipping system was built around one main idea: efficiency. Bigger ships, standard containers. Fewer routes, larger ports, faster cranes, tighter schedules, lower costs. And for decades this worked. It made shipping incredibly cheap. It allowed companies to build global supply chains. It made products available at prices that would have been impossible in the past. But efficiency has a hidden cost. An efficient system often has very little spare capacity. Spare ships cost money. Empty warehouse space costs money. Extra trucks cost money. Backup routes cost money. So companies remove the backup. They remove the empty space. They remove the extra time. And the system becomes lean. But when disruption arrives, the missing backup suddenly becomes important. The same choices that made shipping cheap also made it vulnerable. This is the central paradox. The system is not broken because it is badly designed. It is broken because it was designed too well for one version of the world. A stable world. A predictable world. A world where everything arrives just in time. But the real world does not always work that way. Ocean shipping still looks simple from the outside. A container gets loaded. A ship crosses the ocean. And everything arrives eventually. But now you know that is not really what is happening. Behind that simple journey is a system where delays can be intentional, where speed is not always the goal, and where one small problem can quietly spread across the entire world. A container stuck in one port can affect prices in another country. A shortage of trucks can slow down ships thousands of miles away. And a system designed to be perfectly efficient can become fragile the moment something goes wrong. But here is the part most people never think about. This system is not slowing down. It is growing. More goods. Bigger ships. More pressure. Which means the same problems are not disappearing. They are scaling. So the next time something you ordered arrives late or suddenly becomes more expensive, it might not be a simple delay. It might be the result of a system that is still working, but is slowly breaking under its own weight. And once you start noticing that, you begin to see it everywhere.